Alright guys, so for my second explainer video this week, I was assigned problem 15x, which says to sketch the trajectory of a simple harmonic oscillator over the course of one period, where the y-axis is velocity and the x-axis is the position, and both of these are rescaled by the square root of half of the spring constant and half of the velocity and the spring constant respectively. And then it says to explain the trajectory on following periods. And then part B is just to do the same thing, but to also include a damping force. Okay, so doing this. So the first thing I noticed, and the problem mentions that the rescaling of the constants is, or the rescaling of mass and the spring constant is meant to be a hint, and I'm not sure if this is right, but I took this as a hint that this is an equation of a circle. So while your typical like simple harmonic motion graph might be amplitude vertically and then kind of wiggle off like so, this one is just a circle graph, which I think makes sense because if position is on the x and velocity is on the y-axis, basically that means every time the function, or not the function, every time the circle crosses the x-axis, you have basically the mass getting to the end of the spring system. So like if you were to like drop something from an elastic string and it was to like slow down at the end and then bounce up, the place where the path crosses the x-axis would be the bottom, where it slows down to a speed of 0. And yeah, and this is an ideal system in this case because if there's nothing to slow it down, the circle will just keep overlapping upon itself. So as for the part of the question that says describe what will happen in subsequent periods, this will just follow the same exact path forever, I believe, if there's no exterior forces placed on it. But then for part B, in the second case where we have a damped version, this is the same thing, except since there's a damping force now, the circle will kind of spiral smaller and smaller until it eventually stops and returns to equilibrium. So yeah, it's the same basic thing, just now there's a force that's damping the system and slowing the system down. So the same way, the mass will bob up and then speed will go to 0 and then bounce up again, and then it will bounce less and less until it is stationary at the equilibrium point. So yeah, as far as any common pitfalls, the biggest confusion for me was the shifting or the rescaling of the mass and the spring constant. It kind of confused me. But I just tried to keep it simple and recognize that it's the equation of a circle. And yeah. As far as the overall context of this problem, I think it's just trying to get you to understand how simple harmonic motion looks graphically, because I think, especially compared to with various other physics topics, simple harmonic motion is something that can really be understood well visually, at least for me. So for example, like this circle is provides a really good description of how like a spring system will just keep bobbing up and down in the same path unless an external force acts on it, like in a situation like so. Alright, that's about it for this video. Thanks for watching, guys.